Hello, everyone. My name is Maria Chavero-Diez. I'm very sad to not have been able to be there in person today, but very happy still that being able to give a presentation. I work at the Barcelona Supercomputing Center at the Technologies for Biomedical Research Lab, led by Salvador Capella and Josep Lluís Serpí. And today I am going to be talking about the work that we are doing to manage the orchestration of sensitive data from Galaxy to from the EGA, so the European Genome Phenome Archive, to Galaxy. So this presentation is going to be quite high level. I'm going to be talking about first a bit on the background work that has already been done through the years. Then I'm going to specify a little bit more on what we did during the biohackathon last year, European biohackathon, and the current developments that are taking place right now. So without further ado, I'm going to go to the background and previous work that we have done. So as we may all know, accessing sensitive data and clinical data nowadays is quite tricky. We have many regulatory frameworks in Europe, such as the GDPR. We also have the European Health Data Space, but there is an increasing need to develop a shared framework or infrastructure that actually enables the secure access and integration of that data. And within Elixir, that's being worked on in several projects. I'm sure that if I say GDI or UKIM, a lot of you may recognize those names, or 1+MG. So we want to give our own twist to that endeavor, and we are leading an effort that wants to leverage the EGA and the Galaxy platform, following standards from the Global Alliance for Genomics and Health, particularly focusing on the use of crypt4gh for data encryption and decryption. And when I say this, the most asked questions that I get is why Galaxy and why the EGA? And my answer is always, why not? Because Galaxy is a widely adaptable, you can install it so easily platform. And the EGA is also widely used in Europe, so why not try to connect those two very popular, very used frameworks? These developments actually started in an implementation study during 2022-2023. The implementation study was titled Strengthen Data Management in Galaxy. In that implementation study, we actually developed a prototype work that aimed to securely analyze EGA datasets using Galaxy, but was based on custom tools for encryption and decryption. So on the left of the screen, I hope it's the left for you as well, we have a very, very big scheme of how that worked. I'm not going to go into detail in this scheme, but basically we were using the data would come, we encrypted, we had a decryption tool, then we did the analysis, and then we had an encryption tool again. So what we want to do now is kind of try to do the same, but instead of using custom tools, we want to integrate in our Galaxy platform crypt4gh based integrated protocols. This could enable the implementation of federated analysis in the future, and it could help of simplify what's already there. If you are curious on how this was done and how it was implemented, I believe this was my peer Sveinung already talked about it in the Galaxy days that took place in Australia, but here in the presentation, there are a lot of posters and PowerPoints that you can find on F1000. So I'm going to leave them here. And I'm going to go forward to what we actually did on the to further this process at the biohackathon in 2024. So we were granted the Project 22 at the biohackathon last year. that was titled Enabling Secure Data Access from Galaxy to EGA. The scope was, as you can see, very simple. We wanted to allow secure access to sensitive data hosted on EGA or federated EGA from a Galaxy instance. And we took to ourselves to divide this on 3 tasks. We wanted to create a sensitive data-friendly access point from Galaxy to EGA. We wanted to integrate a remote file system inside of Galaxy. And then we wanted that file system access inside of Galaxy for sensitive workflow execution. Almost nothing for a 3-day project. So as it was actually a 3-day project, we had to put a lot of scenario requirements because that was a very broad scope and we actually didn't have that much time to develop it. So we needed some scenario requirements. The first one was that the user that was going to be retrieving the data needed to have an account to EGA, also federated EGA. In the case of the biohackathon, we were using central EGA with an access to a list of EGA datasets. Then we thought that there were no legal restrictions on that data transfer applicable in that scenario, because if we went into legal restrictions, we were not going to be able to develop anything at all during the biohackathon. Then the most important requirement was that the SSH private key of the user never leave their environment. We were only going to use Crypt4GH keys. We also thought that the Galaxy admins of the instance were trusted, because if we we would need to make more changes in the Galaxy platform if we wanted the admins to not be able to see the datasets that were retrieved. And we didn't want to alter any of the Galaxy analysis tools. That was one of the first requisites, and that was one of the things that we actually wanted to change from the previous development. So we actually were able to develop something like that. We created an EGA outbox as a remote core file system that was reachable by Galaxy. So if you went to your remote file system repositories where you could access remote data, you could see the EGA listed there. And if you had an account, you could click there and you could see the data sets. When you check the data sets, if you just retrieve them via SSH, those data sets were reaching the Galaxy platform encrypted. So you weren't able to see the data sets just by SSH pulling them to your platform. But we were able to decrypt those data sets on the fly using the user's Crypt4GH key. So if you were using the Crypt4GH key and retrieve the datasets into your platform, you could see and actually use the EGA datasets and were able to run an analysis with them. So, of course, this has many things that are not exactly compliant with many scenarios. So this works if we consider that the Galaxy platform where we are running the analysis a trusted environment for this kind of sensitive data. If we want to say, okay, no, but we are using a somewhat public Galaxy platform and a Galaxy server, and we don't actually want the data to be decrypted just on the fly, then we would have to make some changes to that development. And that leads me to the current work that we are actually developing right now. I'm happy to say that we were granted one of the projects of the Commission Services of the Human Data and Translational Research tier within Elixir. And the project aims to establish a secure mechanism to orchestrate access to data hosted on the EGA central instance or federated node, this time through a Galaxy server. the ultimate objective of this project is to ensure that all resulting data outputs are encrypted and exclusively accessible to the end users within the Galaxy user interface. This would ideally get the best of the 2022-2023 implementation study solution, include the findings of what we did during the at the biohackathon of 2024, and then reuse what has already been done and try to integrate it from other Elixir projects into this commission service project. The objectives of this work, well, it's to be like identify several user journeys for using sensitive data. So what we actually want to do with that sensitive data, what kind of analysis do we want to actually be running in Galaxy with that sensitive data? We want to try to do it, as I said before, using the EGA, so orchestrate sensitive data access from Galaxy, from EGA to Galaxy. We want to keep using GH4GH standards for that. Keeping with the Galaxy mentality, we want this to be accessible and intuitive. So we want it to be for the users to be able to do it without noticing that something very complex is going behind the scenes. Of course, unit test validations, and hopefully try to present solutions that are based on real world use cases. For this project that is going to run from the beginning of this year to the end of next year, it's likely that we are only going to be using synthetic data, but we want to at least to make it as similar to a real case scenario as possible. And then, of course, disseminate the results that we get with the whole Elixir community and the Galaxy community as well. This project is being done by people from the BSc, the Center for Genomic Regulation, the University of Oslo, the University of Freiburg, and BIM. And we have 5 main tasks. Of course, the coordination task. We have a requirements and needs assessment task. And then we have the 3 heavy hitters that are the creation of the Crypt4GH recryptor services, the interactive end user orchestration within public Galaxy servers, and then the backend infrastructure that would allow for federated analysis in secure processing environments. So, like, what are the final product, once you get that data, how are we going to be running the analysis with that data? As the project started on the first term of 2025, so far we have been working mainly on the assessment and needs of the project. And basically we have been working through what's needed from the EGA, how the data sets are stored, how a user is able to access those data sets. Are the data sets in cold storage, in hot storage? What kind of user interface do I need to deal with it? How the requirements for a compute nodes, and then on the Galaxy side, what does Galaxy need in order to work with for this integration to work seamlessly, basically. So that has been, we have created a very, very long wish list of if everything was perfect, we want to do all of this. And now that we are going to actually start developing the encryption, decryption, and all the other protocols, we will see how much is possible and how much is not possible. So that was it. I told you it was a very brief presentation. I want to thank Wolfgang, Sveinu, Sabela, Pavel, Eugenio, Nicolas, and all the Galaxy community for making this kind of work possible. And yeah, if you have any kind of question or anything, I'd be happy to answer it. Thank you.
Yeah, I'll run around with the mic if you have questions. So then hopefully Maria will be able to hear you online. And now
Thank you.
So
Should I not share my screen now?
It's okay, you can, as you like.
Okay.
Yeah, that's perfectly.
Okay, perfect.
Hi, thanks. I was just wondering, assuming you can download the data and decrypt it, etc., I guess you also have legal requirement on where you store it in the
Yeah.
landscape.
Yeah, exactly. So that's one of the things that we are actually working on right now, because the scenario that we worked on the biohackathon was supposing that the Galaxy server that we had up was on a trusted place. So we were assuming that the data could travel. So there are many levels of sensitive data. There's sensitive data that cannot travel. There's sensitive data that can travel but cannot be decrypted while it travels. So, some solution that we were thinking about is to link what we are doing with the bring your own storage solution that is being implemented with Galaxy. So if we could have a storage that is trusted by the sensitive data provider, we could actually, using the FAIR datasets, only the datasets on the Galaxy server, but the data would travel directly to the secure or trusted storage side.
Yeah, further questions? One more. Okay.
Yeah, maybe this is unrelated, but what about the other direction? Like if you generate sensitive data locally, you analyze in Galaxy. Since you are dealing with this sensitive data for pain, I was wondering if you already have a way in Galaxy to push the data and publish it to EGA.
I'm sorry because I couldn't catch half of the question. So could you repeat, because I got
Can you
that
repeat?
to push data to the EGA. Yeah, that's the last part that I got.
Yes,
Sorry.
I mean, I'm sorry if it's unrelated to your talk, but since you are dealing and you're thinking a lot about this sensitive data, have you ever thought about the workflow in Galaxy to publish your local data to EGA?
That's something actually that we should be discussing, because when you are fetching the data, you're running an analysis, and then you are getting the results. Ideally, those results would be only visible to the end user, but that's very interesting, because if the user already has an account on the EGA, maybe they could upload those results to the EGA. That's something that we don't know if we are able to do. That would be, and I'm only wondering here, but I'm guessing it would depend also on which node of the EGA we're working with, because each node of the EGA has different restriction levels, has different levels of accessing the data and uploading data. So what we are able to do with the results once the analysis is done, that's something that we actually have to discuss and see when we develop a complete user story.
So I would say to this that technically, I mean, just the data transfer the other way around from Galaxy to the EGA, that's almost trivial. I mean, that is just a tiny enhancement of the integration we have already. But of course, you also want to transfer metadata. You need to have access restrictions on the data, and there's a lot of politics behind that, and how you so that would not be something you can achieve automatically by just pushing a button in Galaxy. But like the raw data, yes, I mean, they could travel bi-directionally, yes.
There is this tool, maybe you know, this ENA approach to do that for ENA, but I was wondering if there's any plan to call to EGA, because you have additional requirements on data sets, and you have additional layers to ENA.
Yeah, so for Maria, I repeat the question. So
I kind of heard that we are talking about the ENA upload, right?
Something similar.
Yeah. So
Yeah.
I mean, that would be something to discuss. Right now, we are kind of focusing on the part of getting the data and being able to run the analysis. So we are more focused right now on the part of how the data is encrypted, how is it not. So, but it would be for sure an interesting thing to once this is done, that would be an interesting topic to say, okay, do we want to now to develop a tool in order to upload those data sets back to the EGA or something like that. It's not on the scope of the project per se, but it's an interesting take for sure.
Cool, thanks. Okay, no more urgent questions, then we could continue.
Then I stop sharing. Thank you all.
Thanks.